Welcome, and today we are going to be talking about variation. Another variation, we have direct variation and indirect variation. We also have other type of variation like joint variation, partial variation, and combined variation. So we have direct variation, indirect variation, joint variation, combined variation, and partial variation. But for today, we are only going to be talking about direct and indirect. So in direct variation, two variables are involved. Let's take for instance P or Q. So two variables are involved, P and Q. As P increase, Q will also increase proportionally. So that means P is directly proportional to Q. So let's take for example, if Y is directly proportional to X and Y is 12, Yx is 4. Find the equation representing this direct variation. Note, when we have P here, we said P is equal to Q is directly proportional to Q. So that means P is equal to, we need a constant in every type of variation. So we add a constant to this Q, that will be Q time multiply with K. That will be P is equal to QK or KQ. So here we said Y is directly proportional to X. So what we are going to do is Y is equal to Kx. So Y is 12, X is 4. We are not going to input them into this equation. So 12 is equal to K times 4. And that will be 12 is equal to 4K. Then what we are going to do is to divide both sides by the coefficient of K. That means the number attached to K. So when we divide, the K is equal to 12 over 4. K is equal to 3. So we have only gotten the constant, which is K is equal to 3. Now they ask us to find the equation representing this direct variation, and that is Y is equals to Kx. So that is Y is equal to, we put this K into this equation, that will be 3x. So this is the equation representing this direct variation. So indirect variation is different from direct variation. Direct variation, you have phi is directly proportional to Q. But in indirect variation, P is inversely proportional to Q. And when I say inversely, that means as P is increasing, Q will be decreasing, and as Q is decreasing, P will be increasing. So now let is equal to, remember I said every variation always require a constant. So this will be K times 1 over K times 1 over Q. So P is equals to K over Q. Let's take for example, if y varies inversely as x, then y is equals to, add a constant, that will be k over x. So if y is equals to 8 and x is equals to 4, then that means that, and x is equals to 4, so that means that y is equals to, so we put the number, that will be 8 is equals to k over 4. So next thing we do, we cross multiply k times 1 and 8 times 4. That will be k times 1 is equals to 8 times 4. So that means k is equals to 32. We have gotten k. So if we are asked to find the equation representing this indirect variation, what we just simply do is y is equals to k over x. The simple thing to do is just to input the number of k in this equation. That will be y is equals to 32 over x. So this is the equation. This is the equation you need to get. This is the equation representing this indirect relation. So if we are asked to find x when y is equals to 8, what we just do is simple. We just input this y in this equation, and that is equals to 8 is equals to 32 over x. So what we do is cross multiply. So that will be 32 times 1 is equals to 8 times x. So that will be 32 is equals to 8x. Then we divide both sides by 8. Then that means x will be 3. So that will be x is equals to 32 divided by 8. And x is equals to 4. So this question I'm going to give it to you in the next class. You can kindly drop your comments under the video. So if y varies directly as x and y is equals to 8, x is equals to 2. Find the equation representing this direct variation. And if y varies inversely as x and y is equals to 16 and x is equals to 1, find the equation representing this indirect variation. So today, in our next class, we'll be talking about joint variation